It highlights a key theme that Tyson emphasizes throughout the book: the interconnectedness of everything in the cosmos. What happens at the smallest scales can have profound consequences for the largest structures in the universe.
It makes you feel pretty small, right?
It does, but it also makes you appreciate the incredible complexity and beauty of the universe we live in.
Yeah.
Welcome to Witter. Who Has Time to Read? The podcast that brings deep dives for busy minds. Listen to AI hosts Jane and Dane and get ready to unpack the world's most captivating books in just a fraction of the time. Whether commuting, working out, or just squeezing in a quick break, we deliver key insights, thought-provoking themes, and takeaways you can carry into your day. Don't forget to like, subscribe, and leave a comment. Plus, use our links in the description to purchase this book. Your support helps us bring more engaging book discussions to you. Listen and follow us wherever you get your podcasts. Who has time to read? You do, with Witter.
Welcome back, Witter listeners, to Deep Dives for Busy Minds.
Yeah.
This month is Black History Month, and we're doing something special, a Black Voices series. So grab your coffee.
Yeah.
Buckle up and get ready for a crash course in astrophysics.
That's right. We are diving into astrophysics for people in a hurry by the one and only Neil deGrasse Tyson.
Neil deGrasse Tyson, astrophysicist, science communicator, and director of the Hayden Planetarium.
Yeah.
He's known for making complex ideas accessible and exciting.
And that's precisely what he does in this book. He takes us on a whirlwind tour of the universe, covering everything from the Big Bang to black holes, from the tiniest particles to the vast cosmic web.
It's the perfect deep dive for our Witter listeners who want to grasp the essentials of astrophysics without getting bogged down in the technical details.
Exactly. It's astrophysics on the go.
Yeah.
So let's start at the beginning with the granddaddy of all cosmic events, the Big Bang.
Okay, so picture that everything, all the matter, all the energy, all of space, crammed into a point smaller than a period at the end of a sentence.
It's almost impossible to wrap your head around, right? But
Yeah.
that's the essence of the Big Bang theory. This incredibly dense, hot speck of, well, we don't even know what,
Right.
suddenly began to expand.
Yeah.
And that expansion continues to this day.
And that expansion wasn't just a gentle puffing up. It was a furious, exponential growth spurt.
It was a cosmic explosion, unlike anything we can imagine.
Wow.
And in the first fraction of a second, a period known as the Planck era, the universe was so extreme that the laws of physics as we know them simply didn't apply.
It's like trying to describe the rules of a game that hasn't even been invented yet.
Exactly. It's a realm where gravity and quantum mechanics, the forces governing the very large and the very small, were somehow unified.
Right.
It's a mystery that still baffles physicists today.
And out of this chaotic soup emerged another mind-boggling concept: antimatter.
Right. Imagine a universe where every particle has an evil twin, an antiparticle with the opposite charge.
Right.
When matter and antimatter meet, they annihilate each other in a burst of pure energy.
So the early universe was a cosmic dance-off between matter and antimatter.
Exactly. And here's where Einstein's famous equation EMC2 comes into play.
Oh yeah, I've heard of that one.
It describes how energy and matter are interchangeable, how they're two sides of the same coin.
So all that annihilation was basically converting mass into pure energy.
Exactly. It was a wild time, to say the least.
Yeah.
But here's the catch. There was a slight imbalance.
Okay.
For every billion matter-antimatter annihilations, a single particle of matter survived.
A tiny surplus that would have a huge impact.
Exactly. That tiny bit of leftover matter is what eventually formed the stars, the planets, the galaxies, everything we see in the universe today, including us.
Wow. So we literally owe our existence to that tiny imbalance in the early universe. It's amazing to think about.
It is. And it highlights a key theme that Tyson emphasizes throughout the book: the interconnectedness of everything in the cosmos. What happens at the smallest scales can have profound consequences for the largest structures in the universe.
It makes you feel pretty small, right?
It does, but it also makes you appreciate the incredible complexity and beauty of the universe we live in.
Yeah.
Now, as the universe continued to expand and cool things began to settle down a bit,
Okay.
those fundamental particles, quarks and leptons, started to combine, forming heavier particles called hadrons.
It's like a cosmic Lego set with tiny building blocks snapping together to create bigger structures.
Precisely. And those hadrons would eventually form the protons and neutrons that make up the nuclei of atoms.
Okay, so we're starting to get to the stuff that makes up the world around us.
Right. But there's still a long way to go, and as we continue our deep dive, we'll explore how those atoms came together to form stars, planets, and eventually life itself.
I can't wait. This is already mind-blowing.
Sure.
So we've talked about the Big Bang and that wild early universe.
Yeah.
Now, where do we go from this chaotic soup of particles to the structured universe we know today?
Well, that's where things start to get really interesting.
Okay.
As the universe continued to expand and cool, a critical transition occurred. About 380,000 years after the Big Bang.
Wow.
The universe cooled enough for electrons and protons to combine and form atoms.
So before this point, it was just a jumble of charged particles zipping around.
Exactly. It was like a thick fog where light couldn't travel very far without bumping into an electron.
Right.
But when atoms formed, the universe suddenly became transparent. Light was finally free to travel across the vastness of space.
It's like the universe flipped a cosmic light switch.
Precisely. And that first light, that initial burst of radiation, has been stretching and cooling ever since.
Wow.
Today, we can detect it as the cosmic microwave background radiation.
It's like a baby picture of the universe.
Yeah.
A faint echo of the Big Bang that's still reaching us billions of years later.
It's a remarkable discovery that provides a wealth of information about the early universe. Now, speaking of light, Tyson also delves into the fascinating world of invisible light, the parts of the electromagnetic spectrum that our eyes can't see.
Right. We're talking about radio waves, microwaves, infrared, ultraviolet X-rays, gamma rays, all those wavelengths that lie beyond the visible spectrum.
Exactly. And by observing the universe in these different wavelengths, we can reveal hidden wonders that we wouldn't see otherwise.
It's like we're suddenly able to see the universe in full color instead of just shades of gray.
That's a great way to put it. For example, radio telescopes allow us to study pulsars, those rapidly rotating neutron stars that emit beams of radio waves.
And these pulsars spin incredibly fast. Right? Some of them rotate hundreds of times per second.
It's mind-boggling, and because they spin so fast, we can detect them as regular pulses of radio waves like a cosmic lighthouse.
It's amazing to think that we can study these objects from billions of light years away just by listening to their radio signals.
It is, and then there are X-ray telescopes which allow us to study black holes, those regions of space-time where gravity is so strong that nothing, not even light, can escape.
Black holes are some of the most mysterious and intriguing objects in the universe.
Absolutely. And by observing them in X-rays, we can see the superheated material swirling around the black hole as it's being pulled in.
It's like watching a cosmic whirlpool, a maelstrom of matter and energy being consumed by this gravitational monster.
It's a sight that would take your breath away if you could see it with your own eyes. And Tyson reminds us that this is just a glimpse of the incredible diversity and complexity of the universe. There's so much out there that we're just beginning to understand.
It's both humbling and inspiring. Now, speaking of humbling, let's talk about dark matter and dark energy. These are concepts that even seasoned scientists find mind-boggling.
They are, but Tyson does a fantastic job of explaining them in a way that's understandable, even if it still leaves you scratching your head a bit.
Okay, so remind me again, what exactly are dark matter and dark energy?
Well, we know that the universe is expanding.
Right.
And we used to think that gravity would eventually slow that expansion down.
Right, because gravity is a force of attraction pulling things together.
Exactly, but then astronomers made a startling discovery. The expansion of the universe is actually accelerating.
Wait, so something is pushing the universe apart, working against gravity?
Exactly, and that something is what we call dark energy.
Okay.
We don't know what it is, but it seems to make up about 70% of the total energy density of the universe.
So the vast majority of the universe is made up of something we don't even understand. That's kind of creepy.
It is, and then there's dark matter.
Okay.
Astronomers noticed that galaxies were rotating faster than they should based on the amount of visible matter they contained.
So there must be something else out there, some invisible matter that's providing the extra gravitational pull.
Exactly, and that's what we call dark matter. It doesn't interact with light, so we can't see it directly.
Right.
But we know it's there because of its gravitational effects.
So dark matter is like the cosmic scaffolding holding galaxies together, while dark energy is the mysterious force pushing the universe apart. It's a cosmic tug of war.
It's a great analogy, and it highlights just how much we still don't know about the universe, but that's part of what makes astrophysics so fascinating. It's a constant process of discovery, of pushing the boundaries of our knowledge.
Now, all this talk about the vastness of the universe is making me feel pretty small.
Yeah.
But Tyson reminds us that we're not insignificant. In fact, he argues that we have a special place in the cosmos.
That's right. He emphasizes that we are made of stardust, that the atoms in our bodies were forged in the hearts of stars.
It's a beautiful thought that we're literally connected to the universe on a fundamental level.
And it's a reminder that we have the capacity to understand the universe, to unravel its mysteries, and to appreciate its beauty.
Okay, so we've journeyed from the Big Bang's fiery birth to the mind-bending mysteries of dark matter and dark energy.
Yeah.
We've explored how invisible light unveils a hidden universe.
Right.
But what does it all mean?
Yeah.
Why should we care about astrophysics?
That's a great question, and I think Tyson provides a compelling answer in his book. He argues that studying astrophysics isn't just about accumulating knowledge.
Right.
It's about gaining a new perspective,
Okay.
a cosmic perspective.
So it's not just about facts and figures.
Right.
It's about changing the way we see the world and ourselves.
Exactly. The cosmic perspective encourages us to step back from our everyday lives and contemplate our place in the grand scheme of things.
Correct.
It's about recognizing our connection to the universe, both physically and intellectually.
We're not just observers of the universe.
Right.
We're participants. We're made of stardust, and the same forces that govern galaxies also govern our lives.
It's a humbling realization,
Yeah.
but it's also incredibly empowering when you grasp the vastness of the universe and the incredible chain of events that led to our existence.
Right.
You start to see things differently. Problems that seemed insurmountable can suddenly seem manageable.
It's like gaining a sense of perspective allows us to zoom out and see the bigger picture.
Exactly. And it can also inspire a sense of awe and wonder, a renewed appreciation for the beauty and complexity of the world around us.
Right.
Tyson reminds us that there's still so much we don't know, so many mysteries left to unravel.
It's like the universe is an endless frontier, constantly inviting us to explore and discover.
Exactly.
Now, this deep dive is part of our Black Voices series for Black History Month. And I think it's important to highlight Neil deGrasse Tyson's role as a prominent Black scientist and science communicator.
Absolutely. He's a powerful voice, not just for science, but for representation and inclusion in STEM fields.
Mm-hmm.
He's breaking down barriers and inspiring a new generation of scientists from diverse backgrounds.
His success is a testament to his brilliance, but it's also a reminder that there's still work to be done to create a more equitable and inclusive scientific community.
Right. We need to ensure that everyone has the opportunity to pursue their passions and contribute to our understanding of the universe,
Right.
regardless of their race, gender, or background.
And books like Astrophysics, for people in a hurry, can play a crucial role in making science more accessible and engaging for a wider audience.
Right.
It's a book that can spark curiosity, ignite imaginations, and perhaps even change lives.
It's a great starting point for anyone who wants to learn more about the universe, especially during Black History Month.
Yeah.
It's a chance to engage with the work of a brilliant Black scientist and explore the profound questions that astrophysics raises.
And as we conclude this deep dive, I think it's fitting to pose a few questions for our listeners to ponder.
Okay.
How many other Black scientists and writers have made significant contributions to our understanding of the universe? What systemic barriers have prevented their stories from being widely known?
Those are important questions, and I think it's our responsibility as consumers of knowledge to seek out and amplify the voices of diverse scientists and writers,
Yeah.
not just during Black History Month, but year-round.
It's about recognizing the richness and depth that diverse perspectives bring to our understanding of the world. So keep looking up, keep asking questions, and keep exploring the wonders of the universe, and keep an eye out for those whose voices haven't yet been heard.
It's a journey of discovery that's open to everyone, and it's one that's full of surprises, insights, and a sense of wonder that can truly change your perspective.
Beautifully said. Thanks for joining me on this cosmic adventure. And WHTTR listeners, as always, keep those minds busy.